All right, guys, welcome back. We're going to do something differently. We are going to talk about a LeetCode problem. It is number 67, add binary, and the prompt is, let me just pull it up over here. Given two binary strings A and B, return their sum as a binary string. So let's go ahead and get cracking on that. Now, LeetCode does it a little differently, and I will just go ahead and do it the way that they do. They declare theirs as a var. See my previous videos, I don't really do it that way. I do function name, etc., etc. And then they'll give you some stuff up top that'll tell you what the parameters are. The parameters are A and B, and the constraint is that the return value has to be a string. This is what they give us to start out with. And from there, we're kind of left to our own devices. Now, it is easy enough to get a string or return a regular integer to as a binary. The secret to that is I'm going to go ahead and declare sum first because you'll see why. But let's say let sum equal, or let sum equal 0, and then we're going to say sum is parse int. Parse int has this secondary feature where, okay, so we've passed in a string right here, and it'll parse the integer from that. But you can also tell it what the base value is, and we're going to say it's a base value of 2, and I will explain that what that means in just a moment. So if you haven't dealt with higher level math concepts, you may not be familiar with something like this, but basically you and I normally deal with numbers in base 10, and what that means is there are 10 numbers that you count up before you reach the next. So depending on how you want to look at it, 10 is either the first in another series or the last in a series. But let's assume it's the last. So you've got 0 through 9. That's 10 sets of numbers, and then 10 through 19, 20 through 29. Basically, what it's doing is you're counting up in sets of 10, where every 10th number clocks in a higher number for the second digit. In binary, it's different. So you only have 0 and 1. So you represent 0 like that, you represent 1 like that. But when you count up to 2, you're only given 2 digits to work with, so you represent it like that. 3 is represented like that. 4 is represented like that. 5 is represented like that. 6, 7, and so on and so forth. So you can have bases for anything. Technically, we encounter stuff like this in some sort of fashion in a lot of measurements, right? Feet is counted in sets of 12 or 12 inches. Hours are counted in sets of 60 minutes. Minutes are counted in sets of 60 seconds. There's stuff that you encounter, but the numbers are borrowed or used from the ordinary number line that we have, so you don't really notice that it's sort of its own different base system. So when we want to convert a binary string to a base 10 number, parse int is going to convert into base 10. You can give it binary, though, to convert. So we're going to pass in a binary string, and we're going to tell JavaScript this is a binary string. And then we are going to return some toString. ToString also has its own property that you don't see a lot. If you don't declare it, it's going to just keep it as a regular base 10 number. But you can choose any number between 2 and I think 32 or 36 as the base to specify, and it's going to convert it into that base number. So if I now say add, let's log add binary, let's say I want to pass in 4. What is 4? That's 4, right? 1, 2, 3. That's 4. This should return what looks like 1,000. Yeah, perfect. So that's working. LeetCode's not going to make it that easy for you, though. They're going to pass in numbers that are too big for the regular integer value. The JavaScript only counts up to this number, 9 quadrillion, thereabouts, right? It is 2 to the 53rd power minus 1. And it's minus 1 because 0 gets stored in binary. So what that means is essentially you can have a series of 52, I guess, ones. Yeah, 52 ones. And that's going to be that because everything gets stored in binary in the computer. After that, the computer won't know how to deal with an integer that's higher than that. Most people don't encounter that issue in JavaScript, but there is a workaround, and you could see it in my search history. It is JavaScript BigInt. BigInt is what you do if a number is bigger than that. And technically, I think it can deal with lower values too, but it gets stored weird. You can see that it always has an N behind it. And if you look here, that's binary. So hexadecimal code gets, or hexadecimal numbers, that's when, what is that, 16? Yes, base 16. So this is base 16 number. This is base 8, and this is base 2. So this is telling us right here what we need to know. These each get prefixed with a special tag. And you'll notice if you try to run this in LeetCode, you're going to get kicked back with an error that looks. Let's see if I can go ahead and replicate it. Right now. Yep. You're going to get kicked back on an error right here. So how do we fix that? Well, we are going to go over that right now. So let's see. This is why we declared some up top, because I am now going to put in an if statement, and the if is a.length is less than 2, and no, it can take 52. It can't take 53. b.length is less than 53. Then else. Now we've got to deal with BigInts. So, as you saw here, we've got this. So we're going to need to put this in front of the string because LeetCode is not doing that for us when it's too big. So we are going to say sum equals big int ob plus a plus big int b, and then return sum to string. And big ints can have their own toString. You can see this in the documentation. So sum right now is a big integer, and it has its own toString. And just like before, log add binary there we go. And that is that's the correct answer. You can try to compare it if you want. But there you go. There's the answer, and how you solve that. You can see it's not necessarily all that fast compared to some of the answers. There's going to be some ways you can cut that down, but this is really just kind of, oh, that ran faster that time, a lot faster. This time it didn't run faster. So this time was in 5%, and this 98%. So that gives you an indication of how bad LeetCode is at, providing a good time frame. In fact, if I were to submit this again, almost surely it would be very different. Oh, it's still kind of short. So there you go. That is the answer. Hope you guys enjoyed the video. As always, drop a like, subscribe, etc., etc. Let me know in the comments, obviously, if you would like me to take a look at any other algorithms.